Hi. Good morning. I somehow lost my voice after the Wednesday class, so my voice is a little bit different from usual. Not because of I go to a Halloween celebration last night, but I just kind of maybe lost my voice. But I hope it's okay. Doesn't affect me. One thing, I hope you have a great celebration last night if you have done so, but you haven't, then I got some candy for you in case you want, and you can come out and take some. I just pass around. You can just take whatever you think make you feel a little bit awake. Second thing is, I hope you have already filled in. If time that, please do fill in. When you know your title, please try to write down. It will be expected everyone in the group present 2 minutes. No matter the size of the group, everyone will present 2 minutes so that I can give grades, because your presentation will be important. Okay, as a business class, right? So you would have to able to present. I don't expect the very main point to be presented. Don't give me the detail for presentation, right? That is a useful thing. It's not technical presentation. Rather, you would just a general idea of what you're doing. Okay, maybe you just mention some key point. Okay, you expect me to be a professional business person who knows statistics. So you don't explain me what's OLS, what is the LASSO, what are those. You don't have to explain to me that. I mean, you can assume that the knowledge you have, the audience also have. That's the first thing, okay? And I think last time we learned, where do we stop? Can't really see it with this. Yeah. So, yeah, I think we stop with the Airbnb model. So basically, I think we stopped somewhere for the car, right? But we didn't really get to the LASSO, right? I think we just stopped there. So to start, let us very briefly review what we have done. I think, let me check if I cover that part. We cover up to here. So all the car cleaning, okay? So let's continue with what we have dropped out last time. So today's goal would be, sorry for the sound. Today's goal would be to finish the prediction model and then go to LASSO regression. So for prediction model, what we will learn is to mainly use the root mean square error, RMSE, to be the horse racing exercise to compare different models. Okay, that's where we stop, and then we will learn the actually we stop as well is we do the k-fold validation method, which haven't done. So this will be done before the first break, right? Then we'll do the LASSO regression, and LASSO, as you see here, it will be a machine algorithmic way, machine learning method, or you can say, right, to select variable. So you give them more than several hundred variable, and depend on how complex a model you want. Later you see this parameter lambda, you adjust the one lambda, then you will give us how simple or how complex the model is. Okay, so that would be a way to let the machine to select the model. You give a criteria. So that would be the starting point. Okay, but let us quickly go into the details. Okay. So as we see, y is something we want to predict, and x is something we use to predict y. Okay, and the main thing is this prediction error, and as we know, we will do the basic method. We will do the square term, right? Square that, and I calculate average square error. Okay, square loss. Okay, And this is the mean of the loss function. I think square would be the thing that we would care about it, okay? So, and I think we start there, right? We look at the code, okay? And let's go to the code and just rerun again because we just restart the program. So we just go back to here, not too far away, right? This is the code we start. This is the where we stop here, right? This is the code that we download data, look at the second-hand car prices, right? And look at the features. Why I want to do that? Because we have a car to sell, then we want to know the price to set there, right? So that would be the idea, right? So if you are a website manager, that would be something similar, right? You may have many days in the past, right? Look at the traffics, look at what has been done, then you predict how many bandwidth you should reserve for, say, a big sales date, right? November 11, right? Then there's the way that you can do the prediction. Same idea there, okay? So this data, let me run that part. And after that, we will do the fill in the missing. Some of you told me that I think that's right. We don't really need to run this line for our regression. So I just skip this running, and I just see very few of the fair and new that I just drop it, okay? And I also do some filtering, okay? And after do the filtering of the data again, right? And only left with 300 rows, and then I also drop these not so realistic. So here is the part that require you to have some knowledge about data, right? Because you have to be need some domain knowledge to work on this, right? You can't really just rely on data, right? You need some expert to make the data cleaner, okay? And same as all the machine learning or ChatGPT, what they're doing is they still need the expert to make sure their baseline data, the core data to be correct, okay? So this is the part that still the machine is not able to do it right now, okay? So this is to have a dummy variable for this because they are just conditioned, right? Condition can be free of those, what will remain then, but we use the dummy variable. Same for the cylinder. And then we have the cubic term, okay? And here is the good part of the Python where you can list all the model in the list, right? Then you can run the for loop, okay? So that is the part we covered last time. So you still remember. And then here we have is run the regression, right, for everything, and then I fit the covariance, right? That's where we have stopped, right? So we have this formula there, and then we just install the star glazer so that our table will look much nicer, okay? So if you look at here, if you look at this problem, one thing to do is look at R square, right? And you can see it's increasing. If you get the model more complex, it is expected, right? Because the worst case is you don't use that variable, right? But still, the good thing is adjust R square. You also see it's increasing. So in some sense, it's okay, right? The complex model seems to be better, right? We're adding useful variable. So now going back to here. Okay. And what we want is to do prediction, right? We want to do prediction. So that means that we have to give me the data, right? That is something, my car, what my car is, right? I have the model there. And let's put prediction. We input this data, okay? And this data has to be in a data frame form, because that is how Python read the numbers. So I convert them to the data format and just do the prediction. So what I do is I use the dictionary format, which is convenient to tell what is my car. I convert to Panda series, and then I convert to Panda data frame. Okay. And then I transpose it because this is how data being input there. Okay. So let me copy this code. Okay. I'm right. So this is data point that we want to do prediction, right? And although we just need one model, but it's good form to look at running like all the models. Okay. So what we do is we start the prediction list, MT1, which we will store everything there. Okay. So what I do is for all the equations, I do the for loop. Okay. And then for each equation, I run a ORS, okay? And then I get the prediction based on 95% interval. I get it, and I create a new column that store which model, because I is looping from 0, so I have to 0 plus 1. This is the Python things. And then append it, and then at the end, you combine them and print that out. So that would be the idea behind this code. Let me run this one. Okay, you can see, depend on which model you're using, it will give you different prices you want to sell, right? And also give you the standard 95% interval, okay? Then depending on which one you want to pick, right? Then this is the outcome. So the question is which one to pick, right? Because you give me 5 answers, then it's as good as a analyst, right? But as a manager, you have to decide, right? The analyst, your subordinate give you this. Okay, you still have to make decision. Which one to pick, right? Which one you want to sell, right? Of course, these are the 5 options, but which one to pick will be the idea, what we call model selection, right? We give the 5 model prediction, but which one is good? So one of the usual problem is when we often see is when we get to more complex data, usually the root mean square error is decreasing. More complex model usually predict better. But when you actually get to live data, go to practice, it just look like this U shape. Okay? There's somewhere the sweet spot there is intermediate. Okay? I think that explains our Chinese culture, old teaching, 中庸, right? Somewhere in the middle is the best. Right? Not too extreme, not too high, not too low, somewhere in the middle. So actually that applies in our model selection. Very often this is something is there. You will see in our model indeed, okay? So the way to go, as we have seen, right, you can do adjust R square, AIC, BIC, okay? Because adjust R square already take into account of the parameter there. You punish that. AIC, BIC also do that. Later we will do that, okay? And one important method later you will see is we mimic the idea behind this one, right? The idea behind this one is when the data you feed in this one, why it performs so badly is because what we call overfitting. It's because you are trying to tune the model to some special cases or some special features only exist in the data, and which is not inherent or what is not built in the underlying original model. Okay, you see some special cases, you take it as general, that is what we call overfitting. So that's why one way to do it is not to use all the data to fit. Okay? You would say, I take first 80% to train the data, to train the model, okay? We remain 20% to see how it performs, okay? First 80% or 70%, is used for train different models, and remaining 20% we kept, okay, used to evaluate the model. Okay, so that is called the validation method. And the other one is called K4 validation. Okay, and the idea is I have 80%, 20%, right? But this 20% is fixed, right? So I randomize this 20%, okay, in several ways, right? One of the good pictures is in your slide, like this one. I just go a little bit step ahead a little bit, like this one. Okay, this is the way that we'll be doing in the Python. Don't worry, it will be just one code. So there will be some for loop there. We will do 2 double for loop. But what it's doing is, okay, this is the data you have, right? You pretend this is the data we have, right? This is the original data, right? This is the live data. We see how it performs for different model, okay? And then in the other universe, you pretend this is something live data, right? Or test data, right? And you train the data based on this blue region, and then evaluate based on this. Okay, so this run for different model, and you run 5 different sets. You can go as many as you want, right? Usually 5, and once you did that, you average out model one's modeling error for 5 different scenarios, right? 5 different universe. You average it out, will be the performance you want, right? Basically, you just run 5 different horse races, right? An average outcome of all 5 races will be your evaluation on the performance, right? You evaluate the 5 hypothetical scenario, okay? So that would be the thing that Python already automatically has a code that facilitates this operation. So we go into one by one. So first we do the validation. So let us do the validation. So let's do first that free method, right? Remember, we do is the direct method, which use R square or BIC, right? So let's see, but we'll use all the data, right? But instead of using R square, use just R square, BIC, AIC, evaluate. Okay. So what we're going to do is to use the version method called RMSE. We know how to do that. It's basically just difference of what you have and what you predict, right? And take square and average of those. Okay. And because we have 5 models, so I do a loop over each model, and the modeling equation, I need to get what's the variable y, right? So I just use a split, and the snail, I just get the thing before snail, okay, this 0. I strip because I don't need the space, okay? I take it out, and I run the regression, and I predict, okay? Look at what predict and what's original. So this is based on the full model. Okay, and then output it. The important part is not R square. Actually, we don't need that, but look at adjust. Oh, so we also adjust and look at this part. So let me copy it, then you will see what are we doing there. So this is the data. Okay, and can I do that? Okay. So we adjust R square. Okay. So the model, Let's run it. So do remember our focus on the last 3 columns. Okay. As you can see from this one, of course, R square always increase as expected because it never decrease. But look at R square adjust, okay? It is going down and up, right? Right? It's going up, it's keep going up, R square adjust. So it's still pointing up to the better the model is. And the BIC is giving us a slightly better view, right? The lowest is this guy, right? So model 3 is better if you use BIC. And AIC will give us model 5, right? So it really doesn't tell you which model is better, okay, uniformly, but it do tell us that it's not the most complex model the better, right? So that is the validation, right? Use the whole sample, but you use the measurement that punish for complex model, okay? In that case, it's no longer always you pick the most complicated model, okay? Is that okay? And of course, look at our MSE is always decreasing without any issue, right? But this is not something you want to look at, right? And R square not something you look at, right? When you do horse racing, you use whole data, you have to use the last 3, and which one you to pick is your take, okay? But from here, it's not strong evidence which one to pick, okay? So let us do some more realistic thing. We do validation, okay? Which we will split the data. From some part we'll do training, some part we will do prediction, okay? So go back to the slide. We will use the code called test string split. Is that okay for this one? Is that okay? Please feel free to stop me if I'm too fast here. So what I'm going to do is I will split the data, 70% training, 30% test, okay? The code to be used is rather simple. We'll use this machine learning package called train test split, okay? So basically it's your data, okay? You split them out, okay? Randomly, you have 70% for training, 30% for testing. A random state is any number that you put in as an initial random seed, so whatever number you can put. Why we do that? Because to set the number there, then always the same randomization. Okay. So this will split into 2 data sets. So once we run that, okay, that means that I now, instead of 1 data set, I have 2. Is that clear? So you want to take a look, you can see how many data we have, right, to be now we only have 200 data points, okay, for the test. And if you do the test, right, it will be only 92, right? So the original one, if you want to take a look as well, how many we have? Okay, original 305. So randomly they randomly choose the data point, dissect the data set. Okay. Now what we need is to do validation. So the only key part is here. Not very complicated. The key part is here. This, and this. So when we do the OLS regression, we use the training data to train. When we evaluate, you evaluate based on the tests. Okay? Is that clear? So our MSE is very convenient because it doesn't rely on things, right? You can just train this way. So that's why this is the way we do, okay? And the rest will be same, right? This is the same as what we have seen already, okay? So let me copy this, we do the thing, right? So validation is here. And I copy the rest of the code. Just run, then shouldn't be an issue there. And make it no nicer. And I append it. Okay. Okay. So that would be the code, right? The main point is this guy, right? You just do the test, okay? So now just look code we run, right? And now we can look at everything. That's no problem, right? But these are the indirect method, right? These are direct method, right? The BC just based on the training data. That's what you get, right? And the RMSE will be the one that based on direct method, and you can see the RMSE is indeed lowest for model 3. Right? Look at all this number there. Model 3 is lower. Right? R square is still, this is higher, but this is something we care. Right? So if you worry about overfitting, which is often the case when you look at the model and prediction, I would pick model 3. Okay? And only have 9 variables to worry about. Okay? And this is more complicated. Is that clear? Of course, you can try different way to split the data, right? Because here I have, we have a 7%, right? We can change 80%, depends on your taste, okay? And of course, if you have smaller, right, data set, then probably you usually have a simpler model, right? Because you are not utilizing the special feature of the model, okay? Now, what we want is to, very last step, is to learn the most complicated thing, as we said, is toward the cost validation. And we need a two for loop to do it. Why? Because for each model, we need to run for 5 different scenarios, right? So that means that we need a 5 different model to handle that, okay? And but we don't want to keep track, right, of the 5 data set, right? So that's why the Python will tell us all the data, right? It will draw a number for each row. Say, suppose this one, right, is also come from the same data set, right? Basically, suppose I have 100 data points, right? This means that for first 80, for the first set means first 80 row go to the training, last 20 go to the test, right? So you can, Python actually later we generate something like this. We will have a generation of train and test, okay? And observation, say 1, 2, up to 80, say 100, and then 100, right? In that case, it will be 1, 1, 1, 1, 1, 1, then 0 for the rest. There will be 0, 0, 0, 0, 0, and 1 for this one, right? So that would be something like that for the first one, and then second, and so on. But randomized, it's not exactly like this form, but it will be randomizing over which one to pick, okay? And then this is the full number, first number set number 1, and set number 2 with another randomization, okay? So basically you have a 5 list of this number, and each time you just pick the data based on the number. So that's why we use the ILOC to pick. Okay. Will be more clear very soon. So let me do it. Okay. So what we do is we will use this package Kflow, okay, which is helping us to randomly draw numbers to satisfy what we just said. Okay? Assign 1 and 0 randomly in a fraction according to how much you like to be trained. Okay? So that is the main thing. Okay? And here I use 4, but I think I follow the book, I use 5. I just check it, but you can use 4, doesn't really matter. So that's what we're going to do. Just copy that one. So this is, let's change to 5 because whatever number, it is okay to be quick. Okay, I use 5. That is what we have seen before. So what next is to actually run the code. It's slightly a little bit more complicated. Okay. Here we will, for each equation, okay. So basically we look at each equation, okay. And what we do is I get the y, okay. And here is the key step, okay. I will split based on how many fold is 4, right? Whether I shuffle again, usually I don't because you allow that it's just like you run it and shuffle again, okay? But I don't shuffle because the ordering of data, at each time you do it, you can shuffle. But the easiest is to not to use anything, just the standard package, okay? And here the RMSE test actually will be collecting each universe, each flow, what the RMSE is, okay? So this is the main loop. I loop over every equation, and I loop over every scenario, okay? So let's loop over equation first. Okay, here is I loop over every single equation, okay? Now, for every single equation, I have to do 5 different regression. Let me copy this code, and then I explain, because it might be easier to see it from here. So it will be something like that. So the key point you can see will be like this. Okay? Now, what I'm going to do is, sorry, I have to. Sorry, let's see. Okay. So it will be the do is for the clay dot split, okay? I split based on that, right? For each index is a pair. I will just pick up the train index to the train data, test to be the test data, okay? So I just make it split every time, okay? And why I do that instead of the test string split, because I want to make sure that when I loop every equation, I just do in the same training and set, right? So that's why I do the same thing. And I do the regression based on the train. I do the evaluation based on the test model, and I pen it to the test that gives me every RMSE result. And after that, I put the mean of that, give me the average. Okay? So I basically, for each equation, okay, I look at 5 different universe by the k-split, okay, using the train to train test to calculate RMSE. I append it to the empty list. Okay. I collect them, and I also calculate the average. Then after that, I can output them. Okay. After that, I can do the output. Okay. Each model, I calculate the average. This is something we care. Okay. And we also want to not just the average, but also want each outcome, right? I want to output, I combine, because each round I run, right? I would want to combine each round, what is my result, and I update it. Why update? Because this is a data frame, so I need to use update instead of append. Then, but now this is the list I can append. Okay, so there's a slightly different syntax here. But once you run it, you give me this one. Okay, for those who not fully understood the code, doesn't matter because this is the standard code that you use for your model, right? I mean, when you really want it, it's just the same thing, right? This is the code, really standard code there, right? There's nothing to change here, right? Only thing to change may be this 5 to 4, whatever you think, but other things are pretty standard, okay? But in case you don't understand, ask me, or the AI can tell you basically, right, if you miss any single point there. But I hope it becomes very clear what we're doing. But the main thing is not the Python, right? When we look at the model, what we get, okay? Look at these 3 models. Again, not surprisingly, model 3 and 4 turn out model 3 is the best, right? And they look at the performance here, right? Depends on which one you look at, right? Model 5 is good here, but otherwise it's terrible in other scenario, right? So it's obviously overfitting, right? If you happen to be lucky in this one, it seems to be very good. But you're unlucky, this is the good. So this is not very stable. So that is something that we also want to look at, right? Not just this average, but also the standard deviation, right? You can actually calculate SD, right? How precise it is, because mean is only one way to look at, right? But at least this one seems to be okay, right? In the worst case, it's better than that, right? In some cases, not so good, but overall, it's doing well. In this case, I would put model 3. Okay. Is that okay? So that is what we said, okay? But go back to that means that we go back to the original question, right? Because what we want is to predict the price to sell. And if we want to make a decision now, this is my number, right? This is my number that I would put the price on the website, right? Because model 3 is the thing we like, right? But if you like model 5, it's still fine, very similar anyway. So maybe we're somewhere in the middle, right? That would be the thing that would be the car we want to sell. Okay? So just to quickly recap what we have learned in this before the break. So what we have learned so far is a prediction model, how to do horse racing. Okay? There are 3 different ways to do it. Either you just don't want to bother, run the whole data, check the AIC, BIC, R square adjust, right? Then you can done. And the reason why we don't want to do R square adjust is because you may not be running regression later, right? Because if you do the logic profit, then you can't really compare with that, right? And or later you will see when we do a nonlinear thing, we do next class we do regression tree. This thing R square is not well defined. Okay, and what is left is BIC and AIC. But there's a problem of that when you compare machine learning model, what is the parameter there is not so clear. Only is well defined for regression. Okay, so that's why we are usually don't do this, right? And regression is okay, right? So that's why we do validation method, right? You do the direct method, right? So basically, is you would do the validation, right? Where you separate the data into the test and train, right? You can do one of the scenario and test it, right? Why you do that? Because your model can be very big. You have so many data, right? So probably you just only want to do once, then you're happy, right? You don't really want to do manifold, right? But if your computer is powerful enough, your data is not super huge, you can do this many units to calculate it. Again, you pick the right model. Okay. Of course, this is the cross-validation is the best, right? Because the computer price is not huge, your data is not super huge. You can always do this as a horse racing exercise, then help you to pick the best one. Is that okay? I know you're tired, so let us have a break for 15 minutes. After that, we'll go to a prediction chapter where we will be working on overall prediction, procedure, cleaning data, and then we'll do the LASSO regression, which is probably, you will like, is the first machine learning model approach that we're looking. Okay, so let's take 15 minutes. We'll resume at 10, 30, 32, 33. In the meantime, if you are not too tired, I suggest you can fill in the form so that I know where you don't know very well, you want me to repeat, or I know your progress. Okay, I'll see you in 15 minutes later. So there's still more chocolate if you are very tired, and come and grab some if you want to. So let's see how we are doing. Friends, you like the candy, just feel free to take more if you want to, if you want to stay awake. So the logic, okay, let me explain again since it's being asked. So I explained the logic of the graph and I explained the Python again. So the Python code actually do the following. So we have a list of model, okay, there's list of model. The loop is doing the following. For each equation, okay, for each equation, I look at the split of data. I want ORS, and then 1, 2, 3, 4, 5, average out, okay? So basically, for each model, I run 5 of the data set, okay? And the regression is estimated based on the blue part and evaluate based on the red part. And average outcome of the red will become our performance for the model 1. So let's go to the code again. I hope I explained this. So this is how we run. So the first line, nothing new, but just tell you to use the RMSE. Second line is the K-fold, which we'll use it for dissecting the data into 5 times, and each time maybe 20% and 10% off. Okay, and CV will store what we're going to store. Okay. So what I'm going to do, okay, will be for each equation, I run the following loop. Okay, I run it as we call. I do it for each equation. I fix first equation, and what I do is I get a y from the equation. Actually, it's the same as the price. You can, if you don't like this line, y is just the price. Okay, that's the price because the equation is this one, right? Let's go back to here. Equation are this. I just get the string before this one. I strip it out as I take out the space. Okay. But then the next part would be to run the regression OS based on the current equation using the training data. I feed it. This will be the feed the model. Okay. It contains all the estimation outcome there. And after that, I use this model to do the prediction based on the test, right, which is the remaining blue part, right, the X, right, and then I look at what is predicted there, look at our MSE, look at how the prediction error, right. This is calculating the red part, right, but we calculate red part for each one, so that's why we do loop. And this is the output, right. This is output, which model you're working on, how many coefficient of model, DF is degree of freedom. Our MSE is this one we have predicted. It's model R square, BIC, AIC, and append it to the list there. Okay, and this is how you get this one. Sorry, that is already sorry. Concentrated is sorry. With this one, different is you have to call the K-fold, which tells you the data, which will be in the first round, what are tests, what are the, so this one will tell us here, which are the tests, which are the training. Same for here, we have 5 different numbers set of numbers. Okay, and right, and what we do is for each split of this, okay, and we will just pick up based on the index what are the train with the train one, what are the tests with the test one, and we run the model based on the training, okay, and we look at RMSE based on the predict one, okay, and append it. If you don't like this, you can just write. If you don't like this, it seems a little bit too much, you can separate it into two parts first, right? Is it better? I don't know. Okay, you can write in this one. Maybe this is better to see. You just calculate the RMSE, and then you just append it. And then you run this, right? Everything there, you calculate average, right? You run over all these 5 times, you calculate average of those. Then give you the first entry there, right? You do the output. It's like these 2 numbers, and then you use the zip, right? Which is, this is fold, it's a list, right? Fold 1, fold 2, fold 3, fold 4, fold 5. This is called F function, it's an F string. I think you learned it in the summer, right? Just a list of numbers. If you don't see this one, you can just take this out. You generate just a list of 4, 1 to 5. And then because of this, test is 5 different outcomes, right? You zip it, it just pick them, right? We just give, for example, it will just give you fold number 1 is this number, fold number 2 is this, right? That's called a zip, right? And then you become dictionary because you can only append the dictionary to dictionary, right? Because the output dictionary, so you use update, and this is still dictionary, but you put in the list, right? And finally, you put the data frame. So there's a slightly difficult code because of the different data type, but otherwise, shouldn't be an issue there. I hope that's okay. If not, then please ask me again in the next break, or just continue to leave your message here so that I can see which part is not clear. Yep. So far, so good. Speed is okay. You can follow, that's fine. That's good. Now, and once we have this, I hope it's okay. If you still don't get it, just you can ask me during the break again how to understand that. Okay. Now we come to the second part of our class, which is cover the prediction process. And as I said, we cover important prediction method called LASSO. Okay. So here is a very important graph. That's how you do prediction, and actually this is something usually what you should do for your project as well, right? So you have to first decide what's your question, right? What is interesting to you, okay? And in our course, I think most of the thing we do prediction, right? Only the last 2 we do causal analysis, but I don't think you have time to think about that for your project. So most of people actually in this class would do prediction as your main goal of the project. So you pick something you want to predict, okay? And that is how defining why, right? Because you have to define what you're going to predict, right? In the case we have second-hand car, you want to predict the price, right? That's a very normal thing you want to predict, okay? And you have to define what are the live data, right? How you want to put into practice, right? Maybe your car you want to sell is the live data, right? And then define what are the sample, okay, you want to do, how to collect them, right, where to get those. And then you will have a label engineering and feature engineering, right? Which means that whether you want to predict y or log y or any transformation of y, okay? And x also you need some featuring engineering, whether you want x squared, log of x, right? You learn that as well. Whether you have the interaction, right? Multiply them, later you will see. And these come from the EDA, right? You look at the scatter plot, look at the bar chart, look at the pie chart, you learn the assignment one, right? And you see how you separate them in the group. And then define loss function, which usually the case RMSE. And then you have built up several models and do the model selection, which I've done, right? Once you do that, you do prediction, also done it, okay? And then the last one is the diagnosis, which you also done it, use the y-hat plot, see how fit the model is, right? These are the things that actually you know every single item, but we'll do it now once and for all in the whole chapter. So because after this, we'll enter the domain of machine learning, okay? So we will do everything. So you can see the question we have is what's the y and what the y, right? And then what are the x? The thing is, if you have many x, then if you don't know what is relevant, you ask the machine to help you. That's LASSO, right? Whenever you have IT data, sometimes you have a huge number of observations, right? You look at the website activity, right? You have time, they do the first click, and time and the second click, where they click, right? Whether they type certain key there, whether they make a mistake, say in the test field form, they fill numbers, they fill the wrong thing. There are many things you can record, right? And how they get into the website, where they get out, I mean, when they come back, right? Do they accept the cookie, where they use login, right? What's IP? There's so many things you can record, right? But the problem is which one is important, right? If you have no idea, then LASSO. If you know some idea, then probably you want to use the idea that help you to continue, okay? And of course, if you have company, no idea what's going on, right? That is, the machine learning will help you. Machine try to learn from the data. But so far, we still have some knowledge, then we can employ this. And again, we'll use the cost validation, right? And then do the checking. But let's do one by one. Okay, just the idea here is in the real world, right? You have the data, you separate into the train set and test set, and also you do the live data as well, right? Which is the real thing that you want to work on. Okay, there's a terminology here. And there's some problem of using what y is. Do you want to log y or y, right? Very often it's non-linear, you want to take a log, right? Or other transformation you want to do, right? Sometimes you want to do transformation like this, say, some transformation y over 1 minus y is other transformation you want to do sometime. And the question is whether which one would be more appropriate, okay? And that's very difficult to say. The idea would be if you care about prediction, you just put the y, the things you want usually, okay? If you just want to understand the regression, want to do causal analysis, actually you're okay to find the best fit because that if you want to understand how they're related. If you simply want prediction, the easiest is to pick the one that you think is the most appropriate. Why look at the car case. If you recall this, you can do h squared, right? You can regress the price, h and h squared. The graph like this. If you instead do the log over h, look like this one. They look pretty similar, right? So if you have contracted term, right, you don't really worry about the law. And if you look at the RMSE or other measure, this is better. But the fact that if you take log, the interval will be much larger because of the fact that the technical part is the prediction is just log. It's not just this guy. You have to adjust for this value. That means that the real confidence interval, this can be much larger than this one in a symmetric way. So that's why I said dot model can be much wider PI. So that means that if you really want to do things, your Y should be the one you care. That's usually the best case scenario. You don't want to transform that. Because you can take square term, problem kind of solved, right? So don't take log if you don't need to, right? And you take log, it's because you care about the growth rate, that may matter, right? If you talk about how age change your price, then yes, right? So 1 more year, how much price drop, percentage is something you care, right? Then might be you care that part, right? But if you don't care, you care about the price by itself, then you would use this model, right? So we will say how much price I would drop by percentage if I wait 1 more year, then maybe I can use the law. But if I want to say what should be the price I want to sell right now, then I should use the level. Okay, you can see the detailed discussion in the book, but I don't think I need to talk too much about that. Instead, I want to draw attention to the highlights of this class, LASSO. Okay. LASSO is, as the name suggests, it's called least absolute shrinkage and selection operator. So basically, you just select variable. So you only use it when you have a huge number of X, then you do it. If you have small number, probably you don't need to do that. Just use ORS, right? Just remember there are many techniques, right? From ORS to LASSO to machine learning. If you don't have a lot of data, ORS is done. You don't have to do more. If you have more data, you don't know what to do LASSO. But you still have to pick things, right? Then LASSO cannot tell you the functional form. You still need to tell him. You still have the human learning part. But if you don't want to learn or the data is too huge to do, later you will see we'll do machine learning. Let the machine do everything. Just close your eye and trust the machine. Okay? So later you will see it's not complicated in terms of math. It's simply an ORS, very simple, plus something. Okay? Later you see. Okay? An important part is this tuning parameter alpha. So let's see this one. Okay? The first bullet point we have is the regression equation. Y is a linear combination of X, right? And ORS is simply minimize the sum of square error, right? But if you take 1 over n, take a square root, what ORS do is minimize the RMSE, right? Right? Because you take the square root and over n, the same thing, right? So that is ORS by construction is minimizing RMSE, right? But do note that this is we have to design, right? But what LASSO is doing very smartly, I think it's very smart for them to think, is this is same as this part, right? So let me draw it, okay? In this part, I just where I shorthand, same as this part. Same. Okay? What's new is a blue part here. And you can see if alpha equals 0, everything go back to normal. And if alpha is very big, what you will see? Now, what we do is absolute shrinkage, the name LASSO, means that you would want to care about the size, the value of this coefficient, right? And you want to minimize, that means that the higher the number you don't want, right? You want to make this, if alpha is large, you want to make this as small as possible, right? Consider extreme case. Alpha is super big, alpha is very big, right? Then you simply maybe want all beta are 0, right? You just fit the mean, then the best, right? You just fit beta 0 is white bar, then you're done, right? If alpha is very large, right? So alpha is like 1 billion, 1 million, right? You really don't want it in any model, because any model you get punished by this coefficient. So by this built-in construction, you have a intermediate alpha, right? Take it from infinity back to the real world, okay? Then you simply tell us that, okay, I don't want a lot of coefficient, right? You simply set them to 0 whenever possible, right? As small as possible. So basically trade-off, okay? Once I told you the alpha, okay, or you have some preference over the complexity, okay? I like alpha to be 10, I like alpha to be 5, I like alpha to be 100, whatever you like, you pick a number, then you can do this LASSO. Of course, you can change alpha according to your wish, right? But you will single out what the coefficient that will be best explain what you want to explain. Is that okay? So just to repeat the whole thing, because I think it's important to understand the logic, right? Because the math, this is all the thing, I didn't skip anything, right? But of course, the computer will do the computation, right? So it's ORS, but regression, but this is the part where we care about the size of coefficient, right? And some of you think why we have absolute value here, why don't have square? Yes, you can have square. You have square, it's called the rich regression, but this is not something the book talks about, but we keep the LASSO thing, just with absolute value. You can change the square, change it to fourth term, actually we'll do something similar, okay? But for the book, we do the absolute value, okay? And by construction, the higher the alpha, you want this coefficient to be close to 0 as possible with absolute value, okay? Try whenever possible, they want to make it 0. So that is how you reduce model complexity, okay, by construction, okay? So you can see what we are trying to do is always try to reduce the dimension of the model, right? From cost validation, what we just learned, right? We don't really want the model to be too complex, right? So this is, from the estimation part, from the beginning, we reduce the complexity, right? From cost validation is at the end, we try to reduce complexity, right? This is, I guess it's a good explanation of what we're doing, okay? And let us look at the LASSO. Turn out to be not very difficult, okay? What I use is the, there's machine learning package called skill-learn linear model. I input LASSO, okay? I mean, later I see I can use the stat model to do the same thing, but I think this one is easier, so I do that. So what I do is I have X, I have 3 features, okay? X1 is this, X2, X3, right? This is array, and then Y is like this, right? So what I'm going to do is I have a LASSO. I put alpha. Alpha is the coefficient there, right? It's how heavily you punish the complexity. The higher of that you will punish more. Okay, and you try to feed the data. Okay. So once we do that, let me do that. And this. Yes. I think that's a typo here. Sorry. Please. This is something we do. We fit it, right, based on x and y. And then this is the coefficient. Here you can see the last coefficient is 0. Y, just look at it, y. Look at, maybe I plot it is better, right? Maybe I plot this thing out. You become a little bit more clear what it's doing. Okay, I do a matplotlib, I do a bar chart. Okay. And you will see the model I have is x1 have some value, x2 the main, x3 becomes 0. Okay. Maybe I also run the ORS, right? Because that also, should I run ORS? I think I should run ORS as well. Yeah, let me run ORS as well. So if you run the ORS, okay, you will see there's some coefficient there, right? But 1 and 3 are very close to 0, right? And the reason why, because they are very similar. I look at the data. x1 is 1, right? When 1 is 1, 2 is 2, 3 is 5 different, 7 is 5, and 8 and 9. So they are actually, look at the conversion coefficient, they're very close to 1, right? They're very similar. So when you include them in regression, that will be a huge issue because none of them will be better, right? So in this LASSO, look at the graph again. What we have is, we actually forget about x3. We just focus on x1, then I'm okay, right? So I do not need to worry too much about x3. I can just drop it and focus on model and x1, x2, right? Then that is what we call automatic selection of the variable, right? The machine tells us that, okay, we don't actually need 3, we just need 1 and 2. If you even don't care about that, we just need 2. Right? If you really don't think this is relevant, it's too small, you can just focus on 2. That is our simplest model we can take, right? We have to make a criteria, what can, what doesn't count, right? You say the coefficient is too small, we care about that, right? That would be the thing. Is that okay? So this is a LASSO. Okay. So you can see automatically fit, okay? And if you want, you can use this another way to write it, okay? Called fit regularize. Before you fit the LASSO model there, okay? So we get the same result. Let me show you because I guess that would be more comforting to see there's a 2 ways to do the LASSO. One is using the machine learning code, but the other is there also 0 here, x1, x2. Okay. And so now let's check out the main problem we have right now here. Okay. The main problem is the alpha, the tuning parameter or the hyperparameter, right? What should be the best, okay? And one way to think about that is we will do k-fold cross validation on the data, okay, to see if that would be feasible, okay? And if you look at the Python, if you do it from scratch, you can do a grid search or random search, okay? The grid search idea basically, we will look at all possible alphas, okay? Divide them into, say, from 0 to 1, you take all possible alphas and calculate the best alpha. That will minimize it because look at different alphas, right? You can check by changing different alpha. You can look at the RMSE, right, and see which one fit better, okay? And this is possible when data is small, okay? But if a huge number of alpha, then you will do the random search, okay? I just, for LASSO CV, we don't apply this directly, okay? We can do directly, but there's a LASSO CV, we can do it direct, much faster. But I still want to illustrate these two things because you will be doing this in next class when you do regression tree, okay? I just quickly go over this, but you will see this again in the next class, okay? The key of this will be this called grid search CV, okay, will be this one. Of course, you can have random search, but basically is you try to use cost validation method based on the hyperparameter you have, use the k-fold validation and run your model and find the best, okay? So this is the thing that I think we'll do it in the next class when we do regression tree and random forest method, okay? And other things are the same, right? Because the first page of this slide, it's just creating data, okay? And you run the LASSO, and then you tell me what alpha is. I try 1 to 20, okay? And I use the MP linear space, and I do the table split, and I do the same, and I look at the best parameter, okay? And that tells me the best score, okay? But I guess I'm not going to use it because I tell you a much more convenient, they call LASSO CV, can do faster, okay? But we will do this grid search or random search when we talk about next class, okay? But I just keep there in case you don't like the thing. You can do this because you may wonder why I do this here, but when I do the random forest or regression tree, I do other way around. I just keep there, it's possible to do it, okay? Because look at the menu, sometimes teach you like this, and I tell you other way around, you may ask me. So that's I keep it. Because the LASSO CV, I think is a new package. It's not there, I think it's recently available. So I guess it's good to look at the Airbnb data, okay? Because we will use it again, I think in the random forest exercise. So basically we'll do two data sets, right? One is the car, one is this one, okay? Now the Airbnb data is a lot of observations, okay? And from this website. And you can see the trouble part of this is you have 94 variables, right? And of course, this is already very small, right? But do note that even 94 have an issue of interaction, right? Suppose you interact different variable, it's easy to go to 300 or 400 something, okay? And then that's an issue. The main thing later you see is amenities is very complicated, right? Because maybe whether they allow cats, allow dogs, these are the thing that you don't know where they affect your rent. Okay, so this is the part that become a little bit more complicated. So the business question is, I look at the website data of that one. I have a house to rent, right? And what should be the price? Okay, that is very standard question, right? You want to set the price of your home to be rented out when you're in vacation, right? So, but what should be the price, right? You want to look at the market price. The problem is every house are different, right? If they're only all the houses are the same, then that's very easy. But the problem is everyone's house is very different, so you have to do a slightly different adjustment there. So what we do, we'll download this data from this here, and you will see what we have here. So let's just copy this and run this code. Okay. And what we do is Airbnb here. So let us run this thing. Okay, download data. Take some time, but you can see they have 64 columns. Okay, lot, but already not easy to handle. Now, unfortunately, this kind of data, as you will face in your IT data, is a lot missing. There are many reasons they're missing. Maybe the code is error, someone collect it, it may not be available. So now the first thing to do is, if the Y is missing, what can you do? If Y is missing, let's drop, because we need to train the data, right? They train data. If Y is not there, then there's no point, right? So drop it. I don't know why Y is missing, but happened to be. And the second is cleaning fee and house response rate. And because we don't want to bother how to handle this missing, we just drop this X. Okay? Later you will see why we do that. And how to handle missing sometimes is available to guess from what other data you have. So in this model, you always have the number of people you can accommodate, right? Say how many people you can be there, okay? Then that one, we can infer how many beds there, right? Suppose you can accommodate 2 people, then you can put 2 beds, right? If you don't have data. So that is how you handle the missing. Okay. First, very important part is to check the missing, because it's not the data from the database, right? You scrap it from somewhere else. So check if missing or not. Okay. This is the first thing to do. And then once you do it, you already see that these are the troublesome features that you have to check it out, right? Because if you don't expect this one, you can drop, right, as we said, right? And this number of bed you can infer from number of people, right? And when I have cleaning fees and response rate is too huge, I don't know how, it's not good to fill in something. I just drop these two columns. That's how I do it. And let's see how we do it. Next is, first we do is drop NA and the price, right? Look at the price. If there, I drop. Okay? If there's no price, I will drop it. So this means that I keep only observation that has price. This is the first thing I do here. So once I do it, you can try to check again if the code is done right. Okay? Also check again. Look at the data. Okay? You can see the price is gone. right? Because I drop it. So just make sure you did it right. Because you make sure that when you run any regression, make sure that your data has no NA. Otherwise, you complain and you are very angry. Okay. So just make sure that you make sure everything is done before you run regression. Otherwise, you don't know where you get it wrong. The second, as I said, if number of bed is empty, we can fill this column which is no empty, right? That's accommodation. Number of people accommodate. So you can just fill NA with this. Okay, so this is the way to handle NA. So we do that again here. Okay. And once we do it, we want to check, right? So let's put the check at the same spot. Okay, once we run that, yeah, number of bed is gone. Okay. Now, next, we go to the next one, right? And as we said, these two columns has too many missing. Then I don't know how to handle it, right? If you keep it in your data, then you don't know what to do, right? Either you just drop all the column there, but there's too many to drop at 1,000 something. So the good idea is to basically, okay, I just drop all this observation there. Okay, I just drop. So this, after I run it, I check what are the missing still, right? So I run this. What left is number of bathroom, how many review, okay, each month, and how many days after the first review, okay? These are data that's no review, right? Because number of days of the first review, if there's no review for the property, then there's no, right? So these are missing part. So now, if this is okay, we go to the next one, okay? Is do the bathroom, okay? Bathroom, we can't really fill things, right? So what we're going to do is we fill the median, okay? And I think that is reasonable, right? Because if you don't know, what you expect is the median, right? And because of we fill the median, we want to not to use the precise number. So that's what we do is we use the grouping, 0 to 1, 1 to 2, 2 to infinity, okay? And why I do that, because you can look at the scatter plot of the price and the bathroom, then you will see this is the best way to do. Okay. You can look at the book tells you how to do it, why they do that, but we'll show you the grouping. And the next one, we will have to fill the median, okay? But the problem is, when I fill the median, there's an issue because in the missing, usually they have no review, right? You fill the median, then we have to remember those actually run without the data, right? So that we will have a fill the median with flags. So there are two, you can see I have two different ways to fill the missing. One is exactly fill the median and forget about it, right? Here I fill the median from the group, and then here I fill the data with flag. So here later you will see what I'm doing, okay? After that, we'll break. So here, what I do is I fill the median, okay, based on the non-NAN median, right? This is take out the NAN, look at median, the bathroom, and fill the missing there. And then group them. Less than 1, I call 0. And 1 and 2, I call 1. More than 2, I call 2. Okay? Just group them up. Okay? Okay, this is how we want to do it. Okay. Later you will see sometimes I use this one, other time I use three N and F at the same time. So number and the flat I also use it. And here's slightly more complicated syntax, but let me copy it and tell you what is it about. Slightly a little bit more tedious, but once we're done, then we go to a break. Okay. So remember, what we want is to record which one is when missing. Okay. I call them flat is to remember they're missing or not. Okay. What I'm going to do is for each of them, okay, I look at the end of this. That's why I'll replace, right? Replace means I do the end. Okay, become n days since, right? And I check if it's NA or not. If it's NA, I put 1 there. Okay, if not NA, then it's 0. And this is stored by flat day since. Okay, so just repeat is I have this one, right? I replace by n, right? That would be n flat day since. I check if there's NA or not. If NA, right, then we put 1 there. If not NA, that's 0. So I just record which one is NA. Okay, this is not the smartest scope, but this is something we do. Okay, and after that, I can fill the median, right? I remember which one I fill, right? So that means that I fill the median, but I also record which one I fill the median. Then later you will see I will use this number. Okay. Okay. So now we're done. Okay, with this. Okay, and then after the break, I will go to the last step of data cleaning, and then we'll start running the regression, and then on the LASSO. Okay, so you can see it's very important to clean the data because although in your presentation probably you don't present them, but when you handle data, you need to be very careful how to fill up the NA, how to clean, where to take a square. These are very important. Okay, and it's a practical class. So I try to show you every single step when you do a business case. So hopefully you learn how we do it by repeating many times. Hopefully you know how to do your project, right? That's why we spend a lot of time on doing this, because this is how you do the project, right? You clean the data from the beginning, you clean the data and set the model and run everything down, okay? But let's have a break of 15 minutes and we'll resume at 11:45. Take a break. In case you want to leave comment, you're welcome to do so in here, but otherwise, feel free to take a break. And feel free to take chocolate if you feel a little bit sleepy. Okay. Um, so let's see if you have any question. So I guess, yeah, LASSO, speed is okay. Overall is fine. So let's continue. So here the final preparation is to separate whether they have reviews more than 1 or more than 50, right? So there's filtering group, because say no review means that that's maybe okay, right? Or very neutral, and there's a lot of review means they are very good, right? So that is how being done, and then we nowhere where we've done many times is use MP where to do the thing, to do the job, right? So this is, I think we've done this many times already. You do it in assignment 1 if you do it in the way that we've been doing, right? So that's nothing very special, right? Less than 1 is 0, between 1 and 51 is 1, otherwise it is 2. So that would be step they were doing. Now once we're done, we are ready to work on it, okay? And then, although we do LASSO, we still need to decide what are the basics model that I think depend on your domain knowledge. It should depend on how many people you can accommodate, right? More people, more expensive. How many beds you have, whether the house is apartment or a house, right? The type of property, and whether you rent the whole apartment or just a private location or share, right? And how many days of the review, okay? So that's why you're the base level, okay? We have this, okay? And do note that I flat day since here, which we used to remember whether day is missing or not. Okay? Because we keep this one, we have to use this flat. So this is the basic level we use for our regression. So this is a list of variables for our regression, the baseline. And then we want square term. That's how we create square term here. Okay. And why do we need square term? Because you plot the graph, you will see, but I don't have time to go over that. And next is, I would call this basic add, is look at how many bathroom you have, whether you have cancellation policy, and whether the bed is a good or bad, right? Bed type. And then the review, you have the flat as well, right? You have square term, okay? I think these are very natural, but the most difficult part is the last one, amenities. And let me run this part. So this basically said, I will get the regular expression. I get everything start with D underscore, okay? And get everything there, okay? I do the filter, I get everything. List them and tuple is, you'll become a tuple there, okay? So let me show you this part, because this, the last one is slightly a little bit more complicated. It's more a Python thing, but I guess you shouldn't feel too uncomfortable, right? And if you run this, the key is this guy, right? This is the most part that you don't fully follow, but you will see these are a bunch of the dummies, whether they have gym, right? The hanger, the heating, hot top, a dryer, many crazy things, right? And these are the things that you don't know whether they matter or not, right? Whether they have cat, right? Whether the carbon monoxide detector, there are many crazy things, right? in the data. Okay? With the washer, with the TV, with a lot of smoking, so there's a lot of things. And this is the part where actually we need LASSO, right? Because we don't know in advance which would matter. Seems all matter, right? This is the part that we need LASSO. Okay, and I don't have time to explain, but look at the book that will tell you that different types of the apartment would have different effect on amenity, right? Because if you say in this one, there's some slight difference between whether, say, kids friendly, is it important for full house or private room, right? So these are the things that they care. Okay, so that's why they want some interaction term, right? Because whether house or not will affect how many rooms you have, right? Private or share. Whether family kids friendly or not will affect the room type. So that is the reason, right? If cats and dogs, maybe the house matters, but if apartment doesn't really matter anyway, right? So these are the problem, and then you have amenity here. So these are the all the additional feature that you would care. Okay. Okay. So this x1, x2, x3 will be some additional variable that you would later ask LASSO to select for you. Right? Or the interaction. Okay. Okay. So you can see, even though I have 70 variable, once I interact, I have 300 something, right? So that would be getting more, right? I mean, I don't think you can actually help to decide which are important or not, right? Out of 331. Okay. So here I have, as we say, we have 8 different models, right? The first model is just price and how many people there. And then we have the basic version. And then 3 will be the basic version plus something additional and the review and so on and so forth, right? So I think you can read that without problem. So I just copy and run it because this is just the way that we have set, right? Just, I think you can much easier to see each thing together. So you can see I have dot join, right? Plus dot join means everything in the tuple I will join by plus, right? Of course, you can type off everything out, but this make our code cleaner, right? Say this join plus dot join, maybe I just show it to you. What you get is this guy. Okay? Because basic level is this, right? And I2 plus join means everything in the element will join by a plus, okay? And I combine that, right? Then I will have an equation there, right? So that means that the model 2, let's see, with this, okay? I then run this part, sorry. So it will be just this equation, okay, which you have seen already. Okay, so just a bunch of equation here. Now what left is I have a list that I can do cross-validation quickly. Okay, now I have all the equation there, an equation. Then the first thing to do is to do ORS and do the cost validation. Okay. I will do the 5 code. I think we've seen the code already, so I'll be quick here. I have 20% of the data here. Okay. Okay. Oh, I don't need this slide, sorry. I just do the, I do the cost validation directly. So I just need this one, which you have seen before the break. I don't need this line. I just do this part. I just do the cross-flow validation. Okay. And I just, for each equation, I run it. I think you have seen that before. I'm not going to explain anymore, but these are the same. We just seen. Okay. But let me explain again, because I guess if I don't, then probably you would not very happy. But let me explain everything again here. Okay, let me copy it and then I explain. So let me explain again, because CV is important, right? So what I do is I load RMSE, and then I have the K-fold, right? And then I have the regression package and NumPy and 5 times. Do the CV. I loop over all the equations. There will be 8 equations there. For each equation, I get the Y, and I run the regression based on the whole sample. Why I want to do that? Because I want to check how many N I have, what is the whole RMSE. And after that, I do the K-fold split. Okay, I have the train and the test, RMSE, and I want to look at this. So the only difference is I also record the training RMSE. So that's different here. So I have the RMSE test, I append it, train I append it. The test is average there. And sorry, it's this. Okay. And after I run the FE loop, I calculate average there. So I output all this thing, okay, and then I combine them, because this is seen as last time already. I think yes, that'll be fine. Okay, so let's run this code. was complaining. Okay. Oh, I forgot this. Last time is the M bathroom. It's M bathrooms. There's a typo in this basic thing. Sorry, bathrooms. And then I run this again, and it should run. So you run all the result there, and once I'm done, I want to compare, but I only want coefficient R squared, BIC, training, and test. I just need them, so I just filter. Okay. So that's what I do after I've done everything here. Go. Take 19 seconds to finish. Okay. So that's what I got, right? So I have a lot of coefficient here. Okay. R squared, no doubt increasing, right? And the BIC, you can see the lowest point is somewhere this one, model 4. And RMSE is somewhere, interestingly, when you train the model, this is the one, right? The test model, this is the one, the lowest. So based on BIC, you pick this model 4, and for this, you pick model 6, right? But this one doesn't work very well because you have too many variables, right? So that's where we apply LASSO. Okay. So now we go to LASSO. Is that okay for this one? So this is already seen. So here is to look at the more interesting thing. Look at RMSE because we want to look at the how this performs. So this will be a very nice graph to show. I think I'm not going to explain this particular slide, but because this is just plotting the graph there. So let me do quickly for this one, because this only showed this diagram, right? If you do the train RMSE, it's always down. But when you look at the blue one, is going up there. So it does show that you really want to pick something in the middle, right? Not really to the very end. So this is the graph that we have seen, right? We have shown it. So you pick model 7, right? RMSE. Now we do the LASSO, and I would do the C validation, which I do 20% for the test, okay? And I use the alpha equal to 4, okay? And one thing that I have to say is for LASSO, there's an important step I didn't mention, which often you will see in textbook is if you, sorry, go back a little bit about the regression, the LASSO thing, okay? If you recall how we run regression, if this x1, say, I multiply 1,000, okay? Say instead of I measure things in kilometer, I measure in centimeter, right? Instead of kilometer, I instead measure in gram, right? That everything will go up by 1,000, right? And the beta will be dropped by 1,000, right? If everything scale up, then the beta will scale down, right? So that means that I have to be very careful about the measurement, right? And so that's why when you run this, you will standardize all the features. So you will subtract the mean over the SD. so that everything become normalized, standardized, right? So you just subtract the mean, they got standardized. But the good thing is Python has a code for that, okay? When you run LASSO, you should do that, okay? So that's what we'll do when we do the actual practice of LASSO. So what I do, slightly a little bit more complicated. We'll only focus on the equation A, okay? Because we really don't need it. We will have a package called paths.sy. Why we want that? Because there's a data very long. We only want the thing we need. So this one, I have the data set df, will take me the y and x, okay, based on the equation. Okay, that is, I take the y there, x will be contain 300 variable, the column that I need. Okay, and this is when they do that, they will actually give you a what we call the design matrix. Okay, and the matrix that has some special feature. Okay, so I would call the feature names there, and I split based on the y and x and split it out. Okay, so that is this test string split I did there. Okay. Let me do that. Okay. Basically now I have training set and data set. Okay. Then I can evaluate the model better. Okay. Now, as I said, I need to rescale the data to mean 0. Only the x, no need to change the y. So basically, I just call a standard scalar, and I transform x and y. Okay. I transform that. I scale them. Once I do that, then I'm ready to run the LASSO. Okay. The same I have seen. Okay. I run the LASSO code here. Okay. This is I run the LASSO here. Maybe I did the wrong thing. Did I? Okay. I feed my LASSO code here, and then I displace. What I'm going to do is I only want that common, I run it to that common number. When it is not 0, I just keep it. So I don't want, maybe 0 to 0, 0, 5, I don't care. Right? So I just run to the second coefficient there. Okay. Then why I do that? Because I don't want to keep too many things there. Okay. When I do that, you will see I only left. These are the thing I care. Okay, these are only, of course, I said the 4 will be too huge, right? Maybe if you wanted to change, you say to 1, 2, or 0.5, there will be more coefficients. So suppose I change to 1, okay? The model will be more complex. See, there will be much more column here, okay? But I just change it to 4 because I want to print out the graph look nicer. Doesn't mean the 4 is the thing you should pick, okay? Because once I do that, I can print the graph, okay, which is print out the diagram, okay. I print out this is bar H means the horizontal bar, okay. The bar vertical, and why horizontal? Because you have negative, positive. So that's why when you plot this, is always the bar there. You plot it, this coefficient, and then you put the color there, okay. And the others are pretty much very straightforward. I hope now you know what is it about. This is to add a line as 0 there. Okay. Now, so you will see if I this particular, then this is what you observe. Okay. It's LASSO model, right? With 300 variable, but you basically condense to that small. Okay. And it is a graph, right? And if you want to do the prediction, right? Do RMSE, you can do the same, right? You can calculate the prediction and a mean square error, right? And this will give you RMSE. No, I don't need that. Sorry, the typo. I don't need that. Mean square. RMSE, so it's RMSE. So take a square root of that. That's right. So then, why I do that? Why I just use RMS? Why I do this? Wait, why I do that? Yes, I can use RMS here, right? Why I do that? I don't know. I don't know why I do that. Sorry. What have I done? So I go back. No way, no way. Please don't do this to me. Yeah, that's okay. So I guess I should, I don't need this one. I think this is stupid code. I just need this, right? I don't need this one. I just need this. I think I'm done. Oh. Okay. Maybe I just follow this. I don't know why. Maybe there's some problem with it. Okay. Let me do that. Let me follow what I have written. And this gives me the RMSE. Okay. Of course, this is very terrible because I have made 4. So suppose I make 1. Okay. Then this one will be nicer. If I make something even smaller, I guess, then I think that one will be slightly better, right? So because I don't want to punish for too much, okay? So this is how you do the evaluation of the outcome, right? So finally, we don't want to keep changing alpha by our hand, right? So let the computer to do it using validation technique. Okay. So turn out to be not complicated, very simple. Okay. You just using the LASSO CV. You tell them from where to where you want to fit, right? So I from 0.05 to 1.01. Each time you increase 0.5, you can say up to 4, doesn't really matter. And then you just fit based on 5-fold validation, and you fit the model. Okay? Let me do it. Okay, that is even simpler, right? So just one line of code, and you do everything there. So let me do this. Lambda. Okay. I don't know what number you want, maybe make it 4, all right? 0 to 4. So I have so many model there, okay? What I need is because there are many model there, I want to look the best, okay? And this will give me the best one because I fit it. So this one gives me the best thing among all the alphas. So let's see. Okay, this one. There are many models there. I mean, I actually fit different alphas. Okay, but luckily they give me the best outcome available. It's like this model. This is the best model. Okay, but you still don't know which one to pick, right? Because there's 0 there. Okay, so this is the model, and here I only show that when the coefficient round to theta complex is not 0, right? So that means that if I take away those things non-zero, I have 71 variable, right? Remember the beginning, how many we have? 300 something, right? So basically I cut out the model into this particular form, and then I can calculate the RMS ME, right? Or you can look at this one, right? Try to look at this graph, okay? See how many variables you got. We have 70 something. Still will be a huge thing. So I don't think we can really see it, but this is all the variable there. Okay, although it's crazy to read, but I mean you can make it longer to read, but this is how you do the LASSO, right? You select the model, right? Because at the end of the day, you don't really care which one is big or small. You care about the prediction, right? So the main thing is to look at the prediction. And the thing to do is to look, this one is look at all possible alpha and see what they look like. So if you want to do it, you can just check it out because I run many times based on different alphas, right? So I can easily check this one by one. Okay, you print out the RMSE for different alphas, right? Alpha from 4 to alpha from 0.5, right? So different alpha give you different RMSE, right? Of course, increasing alpha will give you the RMSE higher, right? In general, right? But it depends on how the train and text related, okay? And this, you can pick the lowest one, okay? This will be the, tell me the fit the best alpha, what is the RMSE, which is 37.98. If you recall, the linear regression model, the RMSE is 40 something. Just go back, oops. Just go back to, this is 37, right? When we run ORSE, you go back to the very beginning, slightly before that. We run this, model X by itself is 40 something RMSE, right? But we're able to, if you do the LASSO, then we can reduce to 37, which is even better than the best model you can think of. So kind of let the machine to select variable actually helps, right? Because 37 is significant, right? Because 40 something, right? It's 40. 37 is like 10% drops, right? So that's why here we saw that, we said that so much better, right? So if you really like, use your brain, model 7, because that would be your brain process tell you. But if you like the data driven, you do a LASSO. Of course, you don't really know what it's about, right? There's some coefficient there. You put in data, you predict. It's hard to interpret, right? But if you really care about the 10% drop, is it sufficient for you? Then you can check, right? Because they will tell you which 71 will be important, right? Because although I don't have time, but you can easily check what are the 71 number there, right? And then you can refine, right? But of course, LASSO can be the first step, right? Because LASSO tell you what are important. Then you can go back to the ORS, pick the right thing, then probably you get a better model. So LASSO need not be the end of the story, right? Because it helps us to check which things are important, and you can go back to run the regression, then you have the business interpretation. So for business manager, right, you don't have to rely on LASSO, that's the end of story, because IT manager may be okay, right? But if you do business, you can tell, the data tell you these are important, right? Just like in this case, right, maybe wheelchair accessible and cancellation is important, right? Then you can put it back in your regression, and that will become meaningful model, right? Because if you try to form a business strategy, right, whether you have a house you want to rent higher, then you can decide what policy to do, right? Of course, there's a cost and benefit of each policy there, but that will be the main key we learned today, right? So, of course, the last thing is diagnosis, right? You want to see how well the model is, and here I use the LASSO model, okay, to predict how it looks like, whether it's a good model or bad model. So I use what we have done many times is y-hat plot, okay, and we can do the plotting, okay, based on what we have seen, okay. Then once we plot, then you will see how well is this model. Okay, if you see that seems to be okay, most of the things are there, not too crazy, right? Maybe this model doesn't work very well for higher price, but when the price is around 200, seems to be okay. Okay, so that would be, at the end, we are happy with the LASSO, right? Not too bad. Okay, at the end here, we can combine what we have with the LASSO, right? And then in this will be the concluding thing, right? Because once I combine, okay, LASSO don't have R square and BIC, but you can see which model to pick if you are only based on prediction accuracy, right? And as I said, LASSO is not end of story. If you care further, look at LASSO, what they pick, and you can do a better model, okay? And can guide what to pick there. Okay? So I think exactly what time's up. And just to let you know, our TA already finished the assignment 2 preparation, which means that you can have fun over the weekend. You have 2 weeks time to work on it. You will, if you look at the assignment, just quickly go into that. Where's the assignment? So just quickly go with you in case you want. So basically the same as the first assignment, same idea, but you will be doing, person 1 will be doing what you do in the assignment 1 already, merge the data frame and combine them, but we'll do other data set. And then you do a bin scatter plot, okay? I tell you what to do. And then you do the Lewis, right? Plot the graph, and then do the OS, which I hope now you should know how to do it. And then you do multiple regression, okay? And use the star glazer to combine multiple different regression there. And then I want you to do the validation, separate them into training set and testing set, compare them based on RMSE, BIC, AIC. Okay? And then I ask you to do K4 validation, which I asked you, then you know how to do it today already. And then ask you to plot the Y hat Y result. Okay? And then I want you to do LASSO, and then question 9. Okay? And then lastly, to evaluate the model using a LASSO CV. Okay? So basically, what we have covered this class. Okay? And by working on them, you know how to apply the codes. Okay? It shouldn't be too difficult. Okay? So have a nice weekend. I will see you on next Friday. If you want, take some more candy. See you next week.